After putting the rest of the piping here, the system now looks like this. We are now going to place some instruments, and we start actually by adding some few fittings also, which I believe we should have there. Piping valves we need. Typically you have a gate valve here, and we can choose, well, as you see in the symbol legend here, we can choose a number of different valves. Then, as it by default gives this valve tag, it highlights that this is not allowed, so it doesn't put any tag at all there. We most likely would like to have some valve here, I think. It will say the same. And we put one more here, I think. We normally should have here maybe to isolate also, I'm not sure. That is for the designer to decide. We just show here that this is possible. And we release the valve symbol here. Then we should have a tag here, and we start with 10, I think. Yeah, it will kind of come out like that. Normally you should also put here the open action. See if I can find that now. It's not in the brief section where it should be. It's definitely not status. Open action is here, and we say then that this should be normally open. Okay. And see, it might, no, it's not lying there. Open action should be here then. And this is also a 2-click feature. Now it didn't become so nice. It's a little bit far away here, but that can be adjusted like this. We just leave it. You understand the concept. Should be here like that, and we have here then we're going for, we needed to have a pressure gauge, I believe, here. Okay, we need some piping then. And secondary piping, we go up here and we can make it a little bit longer. We take a valve, this. We give it a tag also as we're at it. This will also be normally open. Like that. We zoom in there a little bit so we can look at this a little bit better. And then we go for the instruments. We should have a normal general field mounted instrument here, like that. And this is not a pipe fitting, so it won't connect here on the pipe, and it will not connect on the pipe at all. So this we have to remove. We need to use connect to process line, and that we can use on the valve like that. Typically. Now this will not be 12-inch. It will typically be 3/4. So we put in that information. We should also show this information now. Nominal diameter component. Nope. That should be the one. And as you see already, with this small amount of piece of equipment, we have a lot of information that should be fitted around here. It's not so nice to have there, but well, this is in the way. Well, so you see that planning is good to be done. Measured variable pressure, and we should have a modifier, instrument type modifier, which is indicator, like that. And it gives us an instrument number, and we're happy with that. So this is how you put an instrument there. It was not so difficult at all. Then we're going to cool this stream now. And that we need to do that properly, we need to control. So we need to measure the temperature on the line. Symbols again, and that all control is by DCS. What is this? Should be yes, we first should show the transmitter. The emitter will not put out, and we need now to have a thermal well, So we need to show that we actually have to have a connection here to the piping. So we use a small secondary pipe here, and we zoom into this so we see how this looks. More fittings. We should have a flange. Okay. No, not like that. Flange 2. We'll check what that is. Go with this one. Like that. We should have the connector process. Okay, good. Normally this is then 2-inch. We have to show that. Becomes 2-inch. It is 2-inch that we need to show here now, that it has a different size, like that. Here, same again, measured variable, temperature. It's a transmitter. We got the number for free, good. And that is almost all. We should want to have the control function then. Wrong again. And we have a line here also. And then this has the same sequence number 723. So T C then will be temperature control when we're ready. Two instruments there, and we are now going to put some cooling water here. So we need more piping, we need utility, typically like this. Now I end it here, which normally is not good enough. All enters and exits when it comes to off-page connectors should be in the side here and here, preferably coming from left and leaving to the right. Now this is a utility, and that has another OPC. So we just make a small version here so we can fit whatever we would like to have here. What you should do when you draft the piping is that you should put the direction that we have not done on the piping like that. So now we say we get the it's concurrent cooling then. That's not what we would like to have, so we change our minds. You may do undo there. So we put the other utility line here then also like this here. And now we go for the direction which will be down here then. We have a smaller one which I will show you now just after this. We have the off-page connectors. And off-page connectors utility. Okay, good. We try to fix one here. Well, there was a lot of versions to be used. 8 in total. We go with this normal one, I think. What happened now? The thing is that off-page connector comes in pairs. So we have put up on one end of the OPC. So, and in this case, the from. So where is the 2? From what drawing does this come actually? Oh, we just to say that it comes from this test drawing here. Okay, and then we send this set stockpile location of partner OPC, it says here. So the thing is that there's a stockpile connected to each drawing. It's a pile with objects that you can fill. And from the stockpile from each drawing you can place them or send them up to the stockpile from the drawing. There is also an overall stockpile for all the drawings in the whole plant. So if you want to move an object or several objects from one drawing to another, that could be an efficient way to do that. Now this is an efficient way to directly send this off-page connector or show where it comes from immediately. So the system will guide you directly to put this in the stockpile for the drawing. So we send it there. Okay. So it comes out then the text for or the tag for the drawing where this is coming from. And we have not chosen, we should have cooling water supply, I believe, here. It didn't work very good. We have to try again. We probably have done something less good here. Fluid name. Why? Should see what we have. Waters. Oh, it should be this, I guess. Here maybe we try this instead. No, didn't. No, it's not. Should be the one we had. Okay. doesn't want to be with me. Now it shows correctly. Okay, we have to update it. So on this side it will be cooling water return then. Oh, it looks like it works. Okay. There will be coming up inconsistencies in principle always when we put out an OPC, because it has problem. The system is poor in evaluating the inconsistencies over the drawings, which is something that we would like Intergraph to improve. We put another OPC here then. The same way we send this here also. That is not the way to do it, but we do that just to show how this works. What you then see is that there is a number coming up here, 7698. That is actually the identity, the tag of this OPC. So the partner OPC will have the same tag, and that makes it possible for us to find it. From distribution drawing. From CVS distribution drawing to CVR distribution drawing. So what can we do then? We can move to that drawing. Typically we open that one then to see how this is done. Then we have to use the engineering data editor a little bit. Equipment. No, we're looking for OPCs. Okay, active OPCs for this drawing. There's two, the 98 and the 99. And here we can see the tag of the drawing numbers. Now we didn't change the drawing numbers to real ones that we can do just now. So we place this in the end here. Cooling water supply from PID. That was what we called the drawing. Like that. And there will be some piping here also. So normally the utility system is only shown here briefly or short, the close connection to the consumer. Then the distribution system inside the unit is shown in another drawing, and should typically be here then, where we should show that now it's the two different utilities here, so it's not much to show, but we should show the connection, how this is branching, and the sectioning valves, and if we have some measurements and where the battery limit is and how that looks like. And that is what we should show on this utility distribution drawing. Then all over the site we have one drawing that shows to which unit the different utilities distributed, and that will show the total distribution system, and it might also show the manufacturing part of this utility. It might also have OPCs to PIDs where this manufacturing of this utility is taking place. Typically instrument air, you have a PID showing the compressors and the storage tanks and the control system for the instrument air, and then from there you have an OPC to the distribution PID all over the site to the different units. So if we close and open this drawing now, CVS will be shown there and CVR will be shown there. We need to change the drawing numbers a little bit. You put out labels also here. We have not chosen any size here, and that we can do. Typically like this. We have a smaller flow direction arrow also that we typically can put here also to the OPC back end, and that will give us the direction in a good way for this line. So we now have utility, and we would like to control the utility flow so we get the right temperature. We then choose valves from the instrument folder to get the proper control valves. It's important that we choose these, otherwise it will be difficult to put actuators and also get the right data. In this case we use this generic controller, as in this state of the design we don't know what it will become. Like that. We need an actuator. We should not have a motorized with hand wheel. In this case we use a piston. There should be an instrument there then to this valve. and this one will then have the same, as it's a controller, it needs to have the same loop tag as this controller. So we will see if we can put the tag here. Sequence number should be 23 then, like that. And we should see, we should have a failure close or failure open for this one. The label for the fail action is underneath the valve, and it's not same as the open action for normal valves, even if it's available in this record also. So we believe this should be fail open. Then you should finalize the labels here. Tag number with balloon. We should show this tag number for the valve here also. You have to place, it's a 2-click, we place it on the wall. Valve, sorry. Like that. We need to do something here. Right click, show leader line, so we show where this goes to. Should actually be coming from the center of the actuator. So we delete this and place it again. Place it in the middle here, like that. Release it. Show leader. Yeah, that is better. We have a problem. There's a and I don't think we can change that. So no, we can't. There's space on this one. Doesn't look nice, but that is what it is. We push this even further out. I'm not so sure that this is the good way to place the label for the heat exchanger so far away. We this is an example, so we just do this now to show how to place the operating line. See, you have a lot of connection points. They light up when you hover with the cursor over the symbol that you want to attach. I clicked. So when we come down here, we will see attach points. You have 3 points. Take the above one, and you can rotate the agitator if you want to have them on the other side. And there we are. We have our control loop here now. Yes, why do we have this space here? It's a good question. I just realized that it's because there should be the measuring variable showing there, of course. So we have a TC, so this is of course a TV, nothing else. It should not be open like that. So the measured variable here, T, and we got the TV as it should be. Sorry, I forgot that, but that is easy to do. As you know, there's a lot of details to pay attention to here.